segment is very simple. This one everyone must have completed by now, right? So Explorer also I think should have been completed. Survival mode also should have been completed. So what's left is more of the lightning part. How many of you have completed the lightning detector? Are you able to figure out the algorithm for it?
No.
So you know the light source. Let's say initially you have set your load threshold to be, for example, 0, for example. Your light threshold will be maybe 3000. Is that how you have initialized your light sensor interrupt? Everyone has used that for the light sensor. Is it okay? Did you use this method? You initialize your light sensor to this value. So if ever you set it to this value, whenever you have your light source, it will go to the EINT freehandler. Right? So in the EINT freehandler, what happens then? Maybe you take note of the time. Let's say this one, right? So you take note of the current time. Maybe let's say the value is 12,500, just for example. And as you know, once your handler completes itself, it is supposed to go back to the main program. So after this, it will go back to the main program. If ever you don't decide to change the threshold, the interrupt will trigger again. This is also possible, but it may not be very efficient. Your program may not be so optimized. So usually, before we move to the main program, some of us may change the value. For example, I will change my load threshold to some other value, which I'm not telling you. Then on my high threshold, I will set it to a maximum value. Right? So what happens in this case? So after this thing, okay, let's say that load threshold is a value x. You will go back to your main program. Your interrupt will not trigger. Okay, never mind. Let's say we set this to 3000. Your interrupt will not trigger unless you remove this light source, right? If your light source remains here, the interrupt will not trigger again. So, let's say the first case, let's say is a lightning. So the first situation is a lightning. What happens in a lightning condition? In a lightning condition, it means the light source, we will remove it, right, within less than 500 milliseconds. So let's say I remove my light source of the 200 milliseconds. So my light source is removed of the, let's say, 200 milliseconds. What happens in this case when I remove my light source? Okay, let's say previously when I placed my light source, suppose the lux value was 3500. But over here, when I remove it, let's say the lux becomes 2000. What happens in this case? Here we have set the load threshold to be 3000. Your lux is 2000, therefore your interrupt is triggered again. So here, interrupt is triggered again, and we take note of the time. For example, light N. Of course, you do not know. Okay, let's say light N equal to ms6. Maybe at that instance the value is 12,700. In your EIMP pre-handler, there's another set of codes which tells if you check every time. For example, whether light N minus light start you check whether it is less than 500. Okay, so if it is less than 500, then you can say maybe you have it flat, maybe so for example, your survival load flag is set to 1. Then it will go back to the main program. So you have your, before you go back to your main program, maybe you may wish to set the load threshold back to normal. So you may set this back to normal, therefore this is how it looks like, and you go back to your main program. In your main program, you will tell it maybe if this is true, and then you go to survival mode, and you can proceed on. Now, whenever you go inside the EIMP pre-handler, you don't know whether it is a low threshold which has triggered it, or whether it is a high threshold which has triggered it. So maybe what you can do is put some other flags. So somewhere you may write some other flag, maybe let's say here. Maybe this flag detect low is equal to true. Maybe somewhere else let's say here I'm not going to tell you the exact algorithm to use for this too, because maybe I should not tell you this way. This is for the optimized method, but it will be difficult to explain it in terms of algorithm. So you can consider another method which is not the optimized one. inside you see lightweight, and you determine whether it is more than 3000, just to know whether you have placed your light or not. Similarly here, you may say lightweight, just to know whether it is less than 3000. So if ever it is more than 3000, usually it means the start of the light condition. If it is less than 3000, it would mean the ending of the light condition. So of course when you do the subtraction, which is 12,700 minus 12,500, the condition is true, so this will happen. And once it goes to the main program, it simply needs to check that flag to know whether it needs to go to survival mode, and then you do whatever you need to do in survival mode. This is a general overview of the lightning detection. I will not say much more, otherwise it's like giving the exact code. But do you get a general idea about the lightning detection? Is it okay? The lightning detection, is it fun? It's working in your case? Yes. Others have attempted the lightning detection? Or you're still working on the survival mode, or what?
Yes.
Survival mode. And I think behind schedule, I don't know, but it feels a bit slow. Need to accelerate a bit. Anyone has some other concerns with the other devices or anything else? PCA 9532, accelerometer, temperature sensor. Actually, if you don't create a flowchart for your OLED, so flowchart in our assignment manual, we have shown you for the 7 segment, right? In our assignment manual. We have also made use, maybe flowchart 1 is for the 7 segment. We have also required you maybe to read the light sensor, temperature sensor, accelerometer every 2 seconds, right? In case you update your OLED, meaning you say OLED put string or something, in case you update it together with this, meaning you're doing this thing in sequence, well, the OLED update will be just 2 seconds. Alternatively, you can create a separate flowchart just for the OLED. And the OLED always refers to the values of maybe you have a variable for light value. Maybe you have a variable for temp value. Maybe you have an accelerometer value. So the sensors above, what they do is simply every 2 seconds, maybe they will update light value. Light value is equal to maybe light rate, just to update the sensor. Maybe temp value is equal to temp rate. Maybe your OLED, you create a sampling time of, let's say, 800 milliseconds, just for example. You can choose any sampling time. So what it means is every 800 milliseconds, it will look at the light value. But the light value, of course, is updated every 2 seconds. So you can control them separately. This will update every 2 seconds, but your OLED, you can control it separately. Of course, when you read it, for example, at time 800 milliseconds, maybe the value is 200. When you read it at time 1600 milliseconds, it is still 200. because it hasn't been updated. These things are updated every 2 seconds. So you can read separately if you wish. Or if you don't want to have separate flowchart, then basically the OLED is 2 seconds, just like your light sensor and motion sensor.
In this way, there will be around one seconds delay, right? Because in my case, there will be sometimes.
No, of course, I don't tell you to put the OLED light update every 5 seconds. You put it to a low value, maybe like 200 milliseconds or 300 milliseconds. You will not notice any delay. Since our reaction time is mostly like near 200 milliseconds. So it's up to you whether you want to have the same flowchart for this, or whether you want to have different flowcharts, meaning one for the 7 segment is updated every 1 second, one for the light sensor, temperature sensor, which updates every 2 seconds, maybe another one for the OLED, which updates every 500 milliseconds, maybe another one for the PCA 9532, which updates every 250 milliseconds. So you can have different flowcharts, it's up to you. So you may need a few flowcharts. The one we gave you in the assignment manual is only for the 7 segment, but it can be easily modified to take care of all the rest. How about others? Anything you want to? Is it okay? Is it fine with you? Anyone?
The reading of assignment pointer is it should be 0064, right?
0060. You mean the offset?
The set values.
No, when you place it on the table, you read X, Y, Z. Is that what you mean?
Yeah.
When you read X, Y, Z, when you place it on the table, it is around 64, 60 to 68.
Yes, yes.
Of course, if you place your board vertically, maybe the y-axis will have a value of 64. If you place it another way, maybe it depends on how you place your baseboard. Usually we place it in this way, right?
Yeah.
So the Z value is 64. But if you place it, for example, in this way, maybe it's the X value which is 64. If you place it in this way, it is a Y value which is 64. So it depends on how you place your baseboard. In our case, we told you to place it like this. So the Z value will have some initial value. So, okay. This is our baseboard. Let's say this is a force due to gravity. Okay, acceleration and gravitational force 9.81 per second square. Our baseboard has this axis, which is a z-axis. So if ever we place our baseboard on the table, initially the z value will detect some acceleration due to gravity, and it's about 64. So if ever you make your baseboard stand in this way, so right now, this is the z-axis. Maybe this could be your x-axis. So this time it is your x value which will be about 64. Your z value will be 0. It all depends on how you place your baseboard. Okay, so you see the z-axis is parallel to the acceleration due to gravity. So that's why it has a value. As long as it is parallel, it's a gravitational force. But let's see in our manual, what did we say here? Yeah, in our manual, we are only concerned about the z-axis. So, no matter what happens, you don't need to care about the other axis. You just take care of the z-axis. If our board stops in this way, let's say this is the z-axis, our z will have a value of about 36 or 30 or something. So ultimately, you cannot hot-code the value of z, but you need to read the value of z right at the beginning, only the value of z, the rest you can ignore. So when you say AC series, it will update x, y, and z. In our case, this value, we set it maybe z initial is equal to z. We do this just once, right at the very beginning. Or rather, z initial is equal to z. So we save that value, and anytime we run our program during Explorer or anything else, usually our z display is simply equal to the z value minus z initial. So we just need to take note of the initial value of z, and every time we offset it. Or is it plus? I forgot, I need to check. So whether it's plus or minus, there is the offset of the initial. Yeah, so this is offset for the z-axis.
So for the value of y and x,
We don't need to care about
just
it.
take the original reading.
Yeah, just directly give it to us. We're not going to read the x and y.
Okay, so the 64 should be the z offset, right?
Yes.
But my reading for the initial reading of that is around 74.
Maybe the accelerometer is not so well calibrated, but you don't need to worry about that because suppose you get 74 here. Later on, if ever you place your base code on the table, z will be around 75, 76. So when you minus 74, you're close to 0. So that offset, you don't need to worry about the exact value. So you should not hard code the exact value. Meaning, don't go and say that initial is equal to 64. You should not hard code it. Instead, right at the beginning, you read the actual value of z, because if you are, for example, on Mars, on another planet, the value of z will be less, for example, 40. Here on Earth, maybe it is 64. Or for some boat, maybe it is 70. Other boat, it may be 56. It all depends. But you will not need to worry about it because you have performed an initialization. You know the initial value. So if you know the initial value, for example, let's say you get an initial value of 56. So the initial value is 56. Later on, when you display on your OLED, if you did not offset, you will have values like 56, 57, around that much. But when you offset the initial, 56 minus 56, you should get around 0. So you don't need to care about the actual value, you just take note of it, you just say the initial value.
What if my the initial the value for y is also not equal? It's like
Yeah, meaning your code is inclined when you turn it on. Usually then y will not be 0. But if your code is on the table,
I put it horizontally.
yes.
The y is 0 approximately.
How big is it?
Maybe 18 or 20 like that.
That's it. That's quite a lot. So when you say printf, let's see, what did we use? Decimal, right? So you printed the value of z or y, and you say you have some big value. Did you try another base code to see? Maybe your partner's base code, just to confirm whether you can zero or not. So if not, maybe you can try on another base code to see what happens. So we will know whether it has to do with the code or whether it has to do with the base code.
You cannot do the calculation for the system.
What do you mean calculation?
We do calculation the z of the 64.
No, you don't hard code it. You should not hard code that value. You don't say 64 because it's different for all the accelerometers. There's some difference. Some of them are not so. Some of the accelerometers are not so good. So it's not going to be exactly 64.
So finally, after the offset, the z can be plus minus 1 or plus minus 1.
Yeah, it will always vary somewhere, let's say between -5 to 5 is a reasonable value. So I think many of you have tested this, you have obtained some values like -1, 1, or 2, around that much. If you get a value like 255, it means you have declared it as unsigned, which is wrong. The accelerometer is integer. If you look there, or in simple terms, for example, light sensor can only be positive values. However, your accelerometer can have negative values and positive values. So this is why for light sensor, usually unsigned values also should work. But for accelerometer, when you declare your variable, for example, my ball, you will not declare it as uint, maybe 32t. This will not work. Usually it should be int. You can use 32t, but it is quite useless. You can just use 8t, because if you look at your accelerometer, accelerometer, into acc.h. If you look at your accelerometer, x is defined as an integer of 8 bits. So it's useless to declare it as 32 bits because your accelerometer is already giving you 8 bits values. It's not giving you 32 bits. So you will have to look there, it is an integer, not unsigned, but integer. So that's why you always declare it as integer, okay? If ever you need to save values for your accelerometer. If ever you declare it as unsigned, what happens in this case? For example, 1, 2, 3, 4, 5, 6, 7, 8. What is this binary value? This binary value is equal to -1. Okay? If you still remember your 2020, this binary value is -1. Alright? If it is considered signed. But if it is unsigned, what is that value? 1, 1, 1, 1, 1, 1, 1, 1. Well, that value is 1, 2, 4, 8, 16, 32, 64, 128. If you add all of them together, that value is 255. Okay? So if ever you say you're saving that value and you consider it unsigned, when you print f, you will get 255 or some big values. If you declare it as signed, you will get the correct value. Okay? So if it's unsigned, you will have 255, then maybe 1, 2, then again 254 or 255, like this. So this is what happens when you declare it as unsigned. But if you declare as signed, it will work. Okay? It's mentioned here. It is signed. Okay, int means signed. Any other doubts? Or is it okay? Is this fine? So, anyone wants to clarify other things? Anything? Anyone?
Go back to the revenue detection. This threshold setting, the changing of the threshold should be happen in the function of the ANC handler, right?
You can do it here, but I don't do it, or rather, this one uses I2C communication to make a change. So when you use this, try to avoid the usage of other things like accelerometer and other, like reading on accelerometer. Don't read your sensors reading the interruption design. So If,
But
yes.
if we read this Latin sensor, it does not show we don't read any sensors inside this right? And if we put this here,
You can do the light read, but it's slightly inefficient, like I mentioned. There are other ways to go around it. But at least, if you are reading the light sensor, don't go and read temperature sensor or accelerometer at the same time. It's going to slow down your program. Let's ignore that part. You can change it inside EINT3. So, suppose the interrupt was triggered. You are inside EINT3. No matter what you do, it will exit EINT3 after some time, right? No matter what you do. So, if you don't do anything, it will exit EINT3. If you make the changes, it will also exit EINT3. So let's say you made the change, it exits EINT3 and goes to the main program. Well, since you have made the change now, currently the left is, let's say, 3,500. You're back to the main program. It is 3,500. It compares it with the with the low threshold. 3,500 is above the low threshold, so the interrupt will not be triggered. It is below the high threshold, it will not be triggered. The only time it can be triggered is when this lux goes below 3,000. For example, you have your torchlight, it is 3,500. It's only when you remove your torchlight that the interrupt will trigger again. For example, the lux becomes 2,000.
that means if I reconfigure the threshold, I
Yes.
can only trigger the high threshold once.
No, but then back in the main program, you can later on, you reconfigure it back to normal.
Oh, yeah.
You can reconfigure many
Before
times.
that, I can only trigger once, even though
Yeah, then it will be triggered only once. In case you did not change the threshold, it will go to the handler, go out, then back to the handler, go out, back again. It will keep going to the handler. In case you did not change the threshold. For example, if your low threshold was 0, your high threshold was 3,000, you put some light of, let's say, 3,500. So it will go to the EINT3. It goes out, but since the light is still 3,500, it goes back to EINT3. It goes out, it is still 3,500, it keeps going inside EINT3. So this is what happens if ever you don't change the threshold inside the interrupt. So some of you may have noticed if you have used printf to place your light on your baseboard, you would have seen, of course, you have even made use of your clear IOQ as well as GPIO interrupt clear. Even after you have done all this, you will see it will still go back to the EINT3. That's because your light value is still above 3,500. So you need to remove your light value in order to stop the interrupt from happening. So usually this will make sense for those who have actually attempted to use a light sensor interrupt. For those who have not done that yet, this will be very confusing and it's going to be really harmful to your grade. Okay? So if you don't do well in this project, usually the result is not so good. So just try to do a good project, please. Any other things you want to clarify? Because the project is very important, like I said. Yes.
Can you tell me what's the function for trigger? If we press the trigger, does it mean that it will go back to the AQR mode?
If you press SW3,
Yes.
no, it does not change mode. No matter what mode you are in, let me see, I should have it somewhere.
那是放在interval，那是放在 EIG。
Okay, so I'll just write it down again. So let's say this is the initialization. This is the explorer mode. This is the survival mode. No matter where you are, for example, if you're inside explorer or if you're inside survival mode, no matter where you are, or even if you're in initialization, what happens is, if ever you press SW3, let's say you're in survival mode, so your OLED will be updated. You will have your light value, temp value, X, Y, Z. So if you press SW3 there, maybe your light value previously is S in survival mode, opposite of S. But if you press your SW3, you have the updated value, maybe 240, 25.2, minus 1, 2, 0, for example. As well as there's some UART communication. So when you press SW3, these two things happen no matter where you are, whether you're in survival mode, whether you're in explorer. When you press SW3, this must be updated, the OLED must be updated. And you have this trigger. Okay, so that's the purpose of SW3, the trigger. When it is pressed, your OLED and trigger is updated.
So the value will not be refreshed.
Which one?
The value.
So you press it once, it's updated only once. It's not automatic.
Even in an Explorer.
In Explorer, let's say you have a timeline. At 2 seconds, you will update light, temperature, accelerometer. 4 seconds, light, temperature, accelerometer. 6 seconds. So it happens like this, right? Every 2 seconds. If you press your switch, for example, here, light sensor, temperature, accelerometer also is updated. But this one also occurs at regular schedule. They are not affected. So here, this will be updated for a short amount of time. You will see some values. Then at 2 seconds, it will have the, another set of values. At 4 seconds, it will have another set of values, and so on. Of course, if you press it many times, here, 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 then you will have these values being updated many times. Okay. So the SW3 is simply updating the values, or rather send some data value out to your terminal. The scheduled sections do not change. They should not change. Sometimes you will encounter this condition. Let's say when you read at a normal time, it takes this amount of time for update. But you press your switch here, you press your switch here, here. What happens? When you press your switch, it takes this amount of time. So let's say switch takes this amount of time. You press it a second time, it takes this amount of time. You have pressed it a third time here. So this is for the third. And this one, which was scheduled at 6, it will actually be read here, just after this one. So it's like every time you press it, it simply means go on and update the values for light sensor, temperature sensor, accelerometer. So it's like your own schedule. It's like, for example, here it takes this amount of time to update the OLED, read the sensors, and so on. But in between, if ever I press my switch, I must not lose that press. Instead, I must schedule it to happen just after the update. So no switch must be, or rather no press must be lost. These are the optimization part. So maybe at least try to do when there's a simple press. These are extreme cases, okay? For example, we press 3 times continuously and see what happens. These are extreme cases we will test. Only the very best program can support this. Usually it's very rare, but there's at least 10% or 20% of students who can do it. In BNG, it's slightly more. Okay, so SW3 is simply the update. The easy way to do it is to make use of a counter, which you can think about. That's one of the easy ways you can do it. Every press increases the counter by 1. As long as the counter is not 0, you need to keep updating the sensors. For example, at time 4 seconds, your counter increases by 1. So therefore, you know you need to update your light sensor and so on. Here you press it, count increased by 1. Here it again increased by 1. Here it again increased by 1. So every time you press, the count keeps increasing. Let's say here, your count will be equal to 4. Well, since it is not 0, I will update my light sensor, temperature sensor, and accelerometer. Then I will minus 1 to my count. So my count is equal to 3. Let me update my light sensor, temperature, accelerometer. Count minus 1, so my count is equal to 2. My count is equal to 1. Well, count is 0, so there's no more reading. So it's just a counter, but this one you can implement it later on. It's some of the advanced features to deal with extreme conditions. The simplest case is just a push somewhere in between, just a press of SW3. So that's the trigger for SW3. Other concerns? Yes.
On the OLED, right, you have to take all the sensors in one line. Can we take you two lines?
So we use a few lines, right? For example, here, 5 lines, 6 lines.
But in the problem statement, see, it's given a format, right?
That's for the UR. It's for the transmission to the interrupter. The OLED has no format. You can decide on your own.
During the survival mode, when the 16 LED starts to turn on, so as long as you detect a light already, you will just the 16 LED.
Yeah, we set all with turn on again.
will refresh.
Yes. All of them with turn on.
I have a condition that the 16 LED, the countdown is very high, which I set to 250, but in fact they are coming at about 500, which is about 0.5 seconds.
Maybe you are reading sensors and updating OLED. Usually when you do other updates, it slows it down a bit.
So I have to stop the sensors from working and concentrate on the OLED.
Usually in survival mode, you are not reading any sensor unless you press SW3. So in survival mode, that's why we say there's no need to update anything. Because once you update your 16 LED will slow down. This is an expected behavior and it can only be solved if you improve on the temperature sensor and accelerometer reading. It's an optimization for extra features. If you don't improve and you try to read the sensors, then the 215 milliseconds will be longer.
Because the temperature is getting by the
Yeah,
MSC.
it's around 500 milliseconds.
Can I reset the MSC?
Then it means you haven't understood how the temperature
But it's still
is
running.
read the code system, that's not how it works. So there are many extra features, but at least get the basic things done. Like just a single press, don't even try the extreme condition. Extreme condition like these things, you test it only after you're confident that your program works totally well. Okay? Any other question? Many of you seem to be quiet. Does this mean you have completed your program? program, and this is very boring. Is it? Or how is it boring? Just to have some idea. Okay.
In the program, right, the UART configuration is making wire or wireless. So can I do
You
wire?
can decide on your own. If you use the XP, you get a small additional bonus. So usually we program everything by wire. Once everything is complete, we just swap to XP. Because there's no need to change our codes. The codes remain the same. It's just we replace the wire with a wireless. Just like your internet cable, instead of using the wire, we can just remove the wire and turn on our wireless. We don't need to change any codes at all. So that's an XP part. But you need to configure your XP to use the XP. Are there doubts?
Are we able to read whether the value is a 1 or a 0 when being triggered? Can we read the value of the interrupt?
What do you mean by you? No, once the interrupt is triggered,
It's always a 1, right?
yeah, alright, it means it's triggered.
Can you detect a 0?
No, why do you need to detect 0? Then it means there's no interrupt. So you do not go to the handler. When there's an interrupt, you go to the handler.
The falling edge.
You can use, for example, I told you interrupt, enable, rising or falling edge. You can decide whether to enable the interrupt at the rising edge or at the falling edge. So this is a rising and falling edge. Usually the example we gave, we make use of rising. I believe for SW3 we make use of rising, right? Rising, then the light sensor was falling. Yeah. So we have to use both ones. So extra features would be your switch number 3, go on and try to use EINT0 instead. It is simpler than GPIO interrupt actually, if you are able to. If you just look at the user manual, it's just a few lines of instructions and you should be able to use it. It's a user manual, it's given. So EINT0 is simpler than GPIO interrupt and it will help you get some more points if you can configure it. So ultimately, your interrupt is only once you go to the handler, you know your interrupt has been triggered. So all you think you'll be able to complete it within the next 5 days? You have Deepavali, right? 1 whole day to enjoy programming. It's birthday holiday, right? Then you have your Saturday and Sunday. I know you have other modules. Any quiz for your other modules or tests? Exam. No other project, only this one. Okay. So you will have your Saturday, Sunday, and Tuesday. I was planning to give you 1 extra week for that. You want it?
Yes.
The exam. But then you won't have much time for your exams. I think exams is important, right? So 1 extra week is, that's the maximum we can push it. Meaning, we are planning to, for those who were scheduled for Wednesday 11, you will be moved to Monday 16, actually. Those who were on Tuesday is a public holiday, but usually the Tuesday group, initially we had scheduled you for Thursday 12, but if you opt for the extension, it will be on Tuesday 17. So I don't know whether most of you prefer to focus on exams or whether that extra week will help you somehow. So if you really want it, then I will tell Rajesh and we will send the announcement tomorrow. is it was a deadline to be extended? Because last time we extended the deadline, they did not have much time for exam preparation. That's an issue of concern.
You extend it.
No way. Exam is not possible. So anyway, maybe we give you the extra time. For those who have finished early, then you can, or rather those who can really finish by next week, then you use that time for your exam preparation. So actually, I think Rajesh or Prabhupada today and at 12, I think you will focus on revision lectures. Revision lectures which actually deals with examination. So make sure you attend it. I don't think that they web course. So you will cover the soft exam questions. So there are many hints there. Try to attend the lectures. Today it will start around 7:30, I think. But today and next week we will cover the revision questions. Other than that, let's go back. Yeah. Any questions you want to ask? Because the next time our meeting is a training session this Saturday. And then next Thursday, I actually want to complete that tutorial also. But for today, do you need any other hints on?
Can a function be called inside integral?
Can a function be?
Can a function be called inside integral? Let's say if I put the actions of the SW3 in the function, then when SW3 is pressed, I call the function. Can it be correct?
Yeah. It's just a function, for example. Okay, no, actually, are you using interrupt for your SW3? So it will go, for example, to EINT3 handler, right? So in the EINT3 handler, you can call a simple function like you name it when SW3 is pressed. For example, then somewhere else you have something like when SW3 is pressed, and there you can write, for example, printf. But ultimately, in your final program, don't use printf. Printf will slow down your program. So maybe you can do some other thing. Maybe light flag is equal to 1. Maybe temperature flag is equal to 1. So you can do many things inside. So when your SW3 is pressed, it goes inside your handler. Your handler has this function, actually. This function is here. So you can either write this directly inside the handler here, meaning if you write this here, then there's no need for this. Or you can just put this as a function, and here you call that function. It's also possible.
So can sensors be read inside a function?
I would not recommend it, because if it is read here, it still means it's being read inside the INT3. You can do it, but your program may be very slow. It may also give you hot fault errors. So the ideal way is, if you say light flag is equal to 1, temp flag is equal to 1, once you go back to your main program, you check. For example, in your main program, you say if light flag is equal to 1, then light read, for example. So you don't do the reading inside the handler or interrupt. You do it after it goes back to the main program. But inside the handler, you simply say, for example, make the flag become 1, so that when I'm outside, I will read it. If you have understood this, actually what happens is every 2 seconds, so it's like every 2 seconds, light flag is equal to 1 if you have made use of a flag. So every 2 seconds your light flag will become 1. So here, once you have done this, light flag becomes 0, so that it's only read only 1. But this optimized way of writing it. In case it's very confusing, proceed with your normal method, but it will be quite slow. And you may need to hot code errors.
The thing is, I'm not able to read the temperature sensor inside it. The value I get is -270.
No, because the MST, rather you're trying to, you're stuck inside the handler for like 100 milliseconds, which is not a good thing. Usually inside interrupt, you shouldn't stay there for long. The temperature sensor takes 500 milliseconds or more to read. It's like you're stuck inside that interrupt handler, which is not good. So usually we use a flag, temp flag. Only when it goes outside the interrupt, it will check. If temp flag is equal to 1, then I will do temp wait. But you do it outside, not inside the handler. The handler only sets a flag to tell you whether to read or not to read. That is one of the better way of writing it. So keep your interrupt as short as possible. Don't get stuck inside. Don't use string like timer wave or printf inside your. For example, timer wave, for loop, while loop. Don't use it inside interrupts. You should not waste time inside interrupt. If you use while loop, at most it's a very short amount of time. It shouldn't be too long. Okay. Other things you want to clarify? So you have 10 more minutes.
For the 7-second update for Explorer and
Yes.
we need to use the for loop, right? To check array to determine inside
No, there's no need for a for loop. Just an if loop will do. Why you need to check and array?
Because for the past the window of 3 seconds, you need to check how many times the an update is.
Oh, that one, the counting of lightning, is it? It's not a while loop. Actually, in your main program, you can do that checking. Maybe you create one flowchart for it. So here you create a for flowchart which is for the checking number of lightning. Okay, another flowchart for that. Maybe you can set it to be every 200 milliseconds. So every 200 milliseconds, it will check your table of lightning, meaning when it occurs. For example, lightning has occurred at 3,000, 3,500, maybe at 4,700, 5,700, and so on. So every 200 milliseconds, it will check this complete table to see how many lightning has occurred over the past 3 seconds. Just like how we have explained on Saturday for the cleaning session, we have shown you how to refer to this circular buffer in some sense. But this is one of the last thing you would usually do. It's very independent actually.
But this one is the update, the time of updating should not be sampled as like 200 milliseconds. It update as soon as the lightning threshold is detected. So
Which part?
common can
Where is it? Oh yeah, it is, should be at the next earliest instance actually. As soon as we actually we give you like 100 milliseconds, 200 milliseconds, or even 300 milliseconds. Because we cannot notice a delay of like 10 milliseconds. It's not possible to estimate this. So this is actually at the next earliest instant, meaning so as soon as possible. It shouldn't. If we say this, then it means it's in the interval when you are checking it. This one also is possible. Okay. So I just mentioned it two ways. The one I just mentioned now, this one makes use of calling words in name. The other way is inside your interval, whenever it's confirmed to be lightning,
It's not lightning, it's lightning threshold.
yeah, lightning threshold means, oh,
That's
that's
not lightning.
as soon as lightning threshold, yeah, it's lightning. This is lightning, right?
Oh,
So as soon as lightning is detected, it depends on how you have written your program. If, for example, if you have followed this method, meaning lightning is only detected in your main program, well, for example, somewhere you determine a lightning has occurred. That's when you can tell it to immediately check this table to see the past lightning values. So when a lightning is confirmed, you can look at this table to know when previous lightning has occurred over the past 3 seconds.
that means the checking process is triggered by the
Lightning, yes. Meaning when it's confirmed to be lightning, this will be checked.
So the checking of this table is not supposed to be a for method.
No follow. No, actually, just to check the table within the table, you may have a small follow for it, but it's very quick. Just to check each row of this table. This row, this row, this row. For example, for index I is equal to 0 to 10, you want to check something. Then you can use a follow, but it's very fast.
But this follow can be used in the interactive function.
You want to use it in the interval. Yeah, it should be fast. If it's fast enough, instead of the for loop, sometimes we write 10 lines of code. But at least if it's fast, you are not. By fast, I mean a few nanoseconds or milliseconds. If you have a for loop to read the light sensor or temperature, then it's already very long. Reading sensors is very slow, but just to check a table is very fast. So this one is reasonable. So I'm quite sure those who have not worked on this part of the very lost. So at least try to get the other parts working. We can still continue to discuss this during the clinic session and next week as we go on. Okay, any other things you want to check? So if not, you can still come to the clinic session to discuss your concerns. I think we should we will inform about the rescheduling of your lab by tomorrow. Or rather, if tomorrow you don't get a schedule for next week, it means the lab has been postponed, meaning you get 1 extra week. So if you are working on it, you will try to delay it. Maybe you want to sign your attendance manually. Yeah, I don't know if you can just